Hello, good afternoon, everyone. Thank you for joining our June webinar. My name is Mary Gadaba, and I'm the sales manager at WarmlyYours. With me today is Scott Rosenbaum.
Hi, everybody. Thank you so much for joining us, and let's go ahead and get started with our presentation.
Okay, so today we're covering the big picture, all about snow melting. Today we're going to be talking about the plan. It's all about the planning. We're going to be talking about the system selection. This is going to be very important for a difference between mats and cables. Application specifics, we're talking about your walkways, patios, staircases, um, simple applications like that. And Scott's going to tell us his favorite topics about the technical rules and codes and spacing and depth. And at the end, we're going to be taking some of your questions for the live Q&A.
Yep, so feel free to join in, ask any questions you have, and we'll be glad to answer them.
So, Scott, what is the big idea today?
We're going to talk about getting your area heated, and we need to remember that the heat doesn't just transfer. You can't put a cable down the middle of something and expect the whole thing to melt. The cable radiates heat about an inch and a half to 2 inches around it. So that's all the lateral spread you're going to get. So if it's 1.5 to 2 inches, your spacing then would be 3 inches to 4 inches. We're going to get into why those numbers are important because each cable placement is going to directly affect the performance of your system.
Definitely. So the number one rule we say starts with your custom smart plan. So before you begin any of your projects, really this is your essential roadmap to eliminating all the guesswork and ensuring a precision installation. Um, we have experts, engineers. We've been doing this for over 20 something years. So let us take that guesswork out of your project by making deliberate choices. So critical spacing, as we just mentioned, getting that engineered layout reduces all the stress on site. We're not trying to have you guys just give you the system and figure it out on your own. We're here to help.
Absolutely. And the more information we have from you at the beginning is going to make it much, much easier for you to do the install because we'll tell you how to do it if you tell us the area you want to cover. I think the number one problem that we have when it comes to doing jobs like this, and I think Mary, you just had one this morning, is where we're not getting enough information. Like, what are the real dimensions?
Mhm.
I need the dimension between this post and that wall. We need that. Well, you can't just say, oh, I'll just fudge it and I'll get to it later because you can't just fudge it and get to it later because you may end up with too much cable
Right.
and you can't cut cable, or you may end up with too little. So it may seem, well, this seems like a lot of drudgery getting started, but doing this little bit of extra, and I'm not even talking about a whole bunch extra at the
Right.
beginning, just a little bit extra at the beginning is going to give you good smart plans. And that's going to, a good smart plan is going to make it much, much easier for your installers to do. So always, always, always verify the site dimensions, how much power you have. It's amazing how many people, when they
Yes.
contact us, go, yeah, I'd like to heat my sidewalk or my driveway. Well, how many breaker spaces do you have in your panel? We only have one. Well, you're
Mhm.
probably not going to get much heating off of one breaker space in your breaker panel. So those are the kind of things that we need to find out is we need to make sure you have a system that works. And if you have a 300 square foot system, it's not going to run on one breaker.
Right. So really, we're trying to just drive home here is to get us those site dimensions, the power requirements. That smart plan is your beginning to end, start to finish. Really gives you the map on how to lay everything out. And if something changes on your job site, the number one rule is let's revise it before installing it. Let's figure out what's changed so we can get you a revision on your installation guide to help avoid any questions or hangups on the project. So with the smart plan, you're going to get the most valuable things is going to be the actual heating mat or cable layout. This is the precision drawing showing you those exact dimensions we're talking about. We give you calculated spaces. So for example, sometimes we're doing cables, sometimes you're using 3-inch spacing, sometimes you're using 4-inch spacing. That's all provided for you on the smart plan detail. Also, we give you the electrical load breakdown. This is the part that you really need to make sure gets handed off to the electricians so that they can check your breaker panels, see if you need to upgrade your service or if you have enough current available service to do the project that you have in mind. Along with that, we give you the operating cost. So one of the top questions people always ask us is the operating cost. How much is this going to cost to run the big system like this? So we're going to figure that out for you on your smart plan. Also, here comes the field information that we need specifically.
We need to know where you're starting, where we're going to start, and the where we're going to start is going to be dependent on where you want your junction boxes. Because the cold lead, the non-heating lead on the embedded heater is only 20 feet long in many cases. So if it's only 20 feet long, that's designed to get from the heating element to a junction box, and that's as far as it's designed to go. The electrician is going to supply power from your breaker panel to that junction box to make that connection there. So we need to know where your junction boxes can be placed because that's where we're going to start running the cables from there. So that's going to be very, very important. Also, we need to know expansion joints because you can't run cable through an expansion joint. We're going to be talking about that later. So we're going to need to know where are your expansion joints if you're doing concrete. To do that, you're going to need to tell us. So also we need to know, are there any areas where we cannot drill, like handrails? Handrails need to be pre-sleeved. You need to know where they are, and you need to put a sleeve there so you can put the handrail right down in it after you've done your installation. So let's take a quick look at the SmartPlan snow melting installation steps along the way. And Mary, you deal with customers all the time that do this. So let's just go ahead and get started.
Yeah, so the simple way to start is by just giving us a sketch. A hand-drawn sketch is great. If you're working with a landscaping crew, if you're doing like patio or stonework or hardscaping, sometimes they can provide you with a nice architectural kind of drawing. That is great. Just send us something like that and we can upload that to, you can upload it online or you can email it right directly to one of your sales reps. We also have a tool that you can actually draw and shape it out yourself using our online design tools. So you can work yourself through a online quote, and then once you get that online quote, you submit that, and then it comes to a sales rep who will help you through the rest of the process.
And your engineers, our engineers are going to design this space for you to make sure that we put the starting points for the mats or the cables where you told us the junction boxes
Correct.
are. We're going to, at that point, know where the controls, what kind of controls are going to be used. All that stuff is there. And then what happens after that?
Then when you receive your smart plan and quotation from us, you're going to review it all. You're going to go over all the details, check all those double dimensions and make sure everything looks spot on to you. And verify the power requirements. That's going to be the biggest key. A lot of times people think, oh, well, maybe I could just, I have 240-volt service, but that doesn't mean, that's going to be enough to do the whole system. Sometimes we need more than just a single panel of 240 service if you have a huge job. But what you get here is it's all spelled out for you very easily. So you can just walk yourself through that quote, see all your line items, see all your electrical requirements, check it out with the electricians and your installers, and make sure that this is ready to rock for you.
Right. You get a dedicated representative that's going to help you through it, and then we deliver the system to you. And then you enjoy clear, heated areas that are going to be great to walk on to do other things too.
So this is where it comes down to, do I use a mat or cable? People ask us this constantly, which is right for me. Well, cable seems less expensive, but mats seem to be easier to install. And that can be true for some projects. Really what we find is our top performer, top seller is the mat because it is fastened, pre-attached to the mesh netting, which makes it very easy to do very long straight runs. We have 2-foot wide and 3-foot wide pieces. These also come in 3 and 4 inch spacing configurations. So depending on geographically where you may be located, sometimes you can use a 4-inch mat. Maybe you have less amperage. Maybe we'll go with the 4-inch mat for that reason. But we do offer both 3 and 4 inch spacing as well as 2 and 3 foot width on the mats. And of course, 120 or 240 volt, which we will help you to determine what you need. The bigger the project, most likely, most snow melting jobs are going to use a 240 volt, unless you're just maybe doing your steps or your walkway or something smaller.
Yeah, 240 doesn't heat any faster than 120.
Right.
That's a common misconception. So that's definitely the case. Also, the spacing of this wire is going to be kind of predicated on where you live. Different parts of the country have different snowfall totals, and that's an ASHRAE. table that we use, and we'll suggest to you, you live somewhere where you can get by with 4-inch spacing. That's going to save you money on the product. It's also going to save you electricity when you're operating it. It may take a little bit longer to heat up and to warm up, but if you're not in a hospital emergency room and you say, you know what, as long as it's clear by the end of the day, I'm fine. Those are two different situations, right?
Right.
A hospital emergency room is not the same as a driveway in a person's home. First of all, that hospital has unlimited power.
Right.
So they can, it's like they have their own power plant locally. So they can use as much power as they need. Whereas in a home, there's only a certain amount of amperage that's available. And the other thing you can use are snow melt cables. Well, it comes down to cables. You're the one that's going to be putting it at the correct spacing, which is going to take a lot longer. And when you're using asphalt, you're not going to be wanting to use snow melt cables. The asphalt people are not going to wait around for you to manually run this cable back and forth at the correct spacing while they're sitting there and their asphalt's getting cold.
Right.
So when you're using snow melt cables, you're going to be using a lot of cable ties, which means those plastic zip ties. You're going to be using 10,000 of them instead of 2,000 of them for the power mats. So just keep that in mind. Make sure, I've been on quite a few jobs where we have run out of cable ties. What do we do now? You're going to go through a bunch of cable ties when you're using snow melt cables. So one thing that is a bonus with snow melt cables is they are available in 208 and 277. So just keep that in mind. But cable is great for stairs, for irregular shapes, working around landscaping, but it is not going to be your friend when it comes to being in a hurry or if you're doing an asphalt job.
Correct. So what it really comes down to is that meticulous planning. So let's talk about your walkways, stairs, and patios, because this is the time of year that people are putting in the new sidewalks and walkways and steps in their homes. So let's think about the no skip zones. And when we say no skip, we're not talking about like la la la. We're talking about let's not skip the important parts and let's see where we might be able to reduce coverage, or maybe we can skip a little bit. But really, we want to hit the path that is meticulous for where you need the melting to occur. As we said, it doesn't laterally spread very far, so we want to get you that nice full coverage width. But there's times, as Scott and I have just said, power is not always available. So we may do something like a hybrid approach. And a hybrid approach is commonly used. We might do mats for a portion for the long straight sections of walkway or patio. But then if you have a curved area or it goes up some steps or something like that, we might use a cable combination. So we do a hybrid approach sometimes. Also, heating the center of the walkway, that could be very beneficial. Let's say you have a very wide path, walkway is 4 foot wide. Well, really, you only need to have a footpath melted. So sometimes you might be able to get away with just a 2-foot heating mat strip versus having to go the whole width of the 4-foot walkway. So that's very beneficial to just do dedicated heating only. And once again, locking in the curves is what we're talking about. So when you're doing a cable, you need to have something to fasten to with the zip ties and an attachment grid to get the proper framework to set up those curves and have a nice, even, continuous spacing where it doesn't look like you've missed patches.
Right. And the next two things that we're going to talk about are things where you're not going to be running cable from one section to another. And that is, you're not going to be running, like if your driveway is pavers and your sidewalk is concrete, you're not going to be running the cable from that paver system over to the concrete walkway. You need to keep it within that certain application. So if you have a portion that's asphalt and a portion that's pavers, there's going to be heating wires in the asphalt and separate heating wires in the other sections. And you're also not going to cross expansion joints, as we've already talked about. So you're not going to be going across those. So keep those in mind. And Mary can tell you that a lot of times when we talk to somebody who's never done a driveway before, their first inclination is, I'm going to heat every square inch,
Right.
until they find out that they don't have enough power to heat every square inch. That's where our experts will tell you, hey, let's cut, let's bring the coverage in a little bit. No one ever goes over there, so you don't need to heat that. And maybe you don't have enough power to do a whole driveway, but you can do tire tracks down the driveway, and that will reduce by 30 or 40% of your electrical load. So let's just take a look at this effortless winter safety snow-free paver walkway
I
that was
like
done
this
here.
one. I like this one a lot, Scott, and I'll tell you why I like this one because it has some sections that are pretty long and straight, but this one does have a bend in it. So when you have a system that has straight runs plus a bend, and it's so much easier to lay out the heating mats, what we do there is we show you how to cut and separate the long, straight, 3 foot wide run of mat and just pull off a little bit of that cable and hold it down to freeform it. So right there, we're telling you to take out 12 inches of the mesh netting, remove that and free form up some of that cable. And on the other corner, we're doing 9 inches and another 9 inches to make those turns. And by stringing that cable evenly like that, we're going to have a nice path. So you're not going to get blobby, unmelted spots. It melts real nice, as you can actually see in that live photo. And isn't that cute?
Yeah, there's a doggy there.
Yeah.
So you can do this one of two ways. You can do this with a mat, as you see now, a hybrid approach. We kind of do a hybrid of a hybrid where we actually take the wire off of the mesh and put it here. Because if you run it as a fan like this, the further those fingers of the fan get apart, the less watts that are per square foot are in that area. And the area where the wire's close will melt really well. And the area where it fans out like this may not melt and will not melt at the same rate. So that's a great picture there of that type of installation.
Yeah, that's a good one. So the cable, never the mats. When is it important to use only the cable? Well, this comes down to when we're talking about steps. Steps is one of those times that it's mats are not the option. You're going to be using a cable so that you can come up the rise of the tread. I'm sorry, the rise of the step and onto the tread. And you want to get that cable pretty tight to the edge of that step too, so that you get the melting effect all the way to the front edge of that step so you don't slip.
Remember, the heat is like a circle, an inch and a half to 2 inches from that cable that surrounds it. So that's why you have to get the cable out on the front of the step, because I have gone out to a half a dozen installations in the middle of the winter and the front edge of their step is not melting.
Yeah.
And there's two reasons why. First of all, they put a huge bull nose on the front, which gets it sticks so far away from the cable that it doesn't melt. And also they didn't think about getting the cable on the front edge. They just kind of kept it back.
Yeah.
So that whole front strip of the tread is frozen. So you have to keep that in mind.
Right, absolutely. So yeah, definitely think about where that cable is going to place on the vertical rise onto the next step to ensure that optimal coverage. Surfacing and making sure that you have the right framework on the steps as well is important. Let's show that picture right there. I think we can get a better example. There you go. That's what I'm talking about. So now here we have the embeddable attachment grid. So we had a concrete set of steps already. They fastened down this, you can see there, that black grid with some concrete screws and washers, it looks like. And then that gave them the formation to figure in that cable. You can really see how they got nice and tight and really nice spacing to melt that whole surface area. And you can see how that cable travels up each step.
Now, when you're doing these steps, there's a couple ways to do this. Many times what you can do is you can run the cable down and make a softer loop, but you can see here where we've actually trenched into the concrete. You're creating a spot for that cable to go down in front, because when you're putting something on the riser, or if you're putting limestone caps, the people that are putting the limestone caps want to put the mortar down, and then they want to move the caps down like this. Well, as they're moving it like this to get it to set, it is cutting through the cable. Right. So that's why you have to get these recessed. Many times you can do a cut and do a loop like this, and then have it go across the front of the riser down to the next step. In most cases, that's the way it's done. Not a direct 90 degrees, because it can get a little tough on the cable. You can do a loop, do it across the front of the riser, and then go down to the next one.
Awesome. That's a great visual.
But that's very, very important. If you don't keep that cable on the front, I'm just warning you now, if you don't keep it on the front of that step, you will have that problem. The best results you're going to get is a step with no bull nose. Now, I know some code requires a bull nose, but if you can get by without a bull nose, you're going to be much, much happier.
Okay. Thank you, Scott. Hand railings. This is something that does get overlooked, and I really think everybody needs to remember, if we are putting in our hand railings, What what do we need to do first? We need to put in a sleeve to help that we don't drill through those hand railing spots and damage the cables. A lot of times that's kind of irreversible damage because they're going to damage it more than once along the way as they're doing it. So really plan ahead for those hand railings to protect them and that nobody damages the
And
cables.
also, you're going to have to show that on your plan when you send it to us,
Mhm.
because we're going to design around that spot where you're putting the sleeve. So it's sometimes it's hard to remember, oh, I need to remember for my handrails, because most of the people I talk to that have drilled through the cable on their putting their handrails in, they go, I didn't even think about where I was going to put the handrails when I ordered this.
Yeah,
Well, those are the people that drill right through the cable. So you really have to think about that in advance. So make sure that the railing contractors are going to tell you, here's where it's going to be, here's the diameter of the tube we're going to use, all that information, we're going to put it on step 1, 3, and 5, that sort of thing, and mark those on your plan and let us know. Because
yeah.
if I were installing this, I would drill into the cable every spot I went down. That's just my luck. It's just the way I roll.
Yes. Okay. So patio size and power here. So when you're doing your snow melting system, as we led on to that, some of these systems are 50 watts a square foot, and that is a pretty high electrical demand. So making sure that you have the proper infrastructure ready to go for that is necessary. So meticulous planning for those placements of the junction boxes. Again, we can't bring that home enough for you. So plan early, get with your electrician. He's one of the first guys you got to get on board to do this. So he can come out and check out your size of your panels.
Yeah, and the electrician is going to be the first one there before the pavers or the contractors or any other people there, because they've got to measure their conduit. They've got to tell you where the junction box is going to be. They've got to install the junction box. Then after all these paver people and all these asphalt people leave, they're going to then be making all your connections. So just don't think that the electrician is going to be there the day of the install. They're
Yeah.
not. They're going to be there a day or two before. They're going to be there during, and they're going to be there afterwards.
Absolutely. Yep. Um, and we mentioned that paver cap too. When you're coming to talking about your pavers, we do want to kind of make sure it's important to let you know that the thicker the paver, the less heat you're going to get through it. So our recommendation is to stick with a 2.5 inch paver thickness, so that you get a good melting effect all the way to the top of the paver. As we said, it only goes about 2.5 inches in each direction. So more than that, it's going to take longer to get through.
Yeah, and if you have a 3-inch paver, it's not going to cause the system to catastrophically fail. We get that question all the time. Well, what if I use 3-inch pavers? It will probably work, but it will heat slower because there's more thermal mass. You're heating a thicker object, so it will take longer, and it may not get as warm at the top. So that's what you're going to look for. We know the system works at 2.5 inches. If you say, yeah, I want to use a 3.5-inch paver,
Yeah.
that's up to you, and it may or may not work, because I can't tell you if it'll work or not, depending on depending on where you are in the country. So you need to make sure that you are doing 3-inch spacing. Let's take a look at this one.
Yeah.
This is one that I personally did, and we were talking about the electrician. Well, when we did this job, we laid the cable out, and the electrician went to put it into the conduit, and he put the splices.
Oh.
He bent the splices to get them into the conduit. Two
no.
major problems there, because as soon as he bent the splice, he ruined it. So me and a colleague had to go out. It was like 94 degrees that day. We had to go out and redo all of that before the concrete guys were going to be there in the morning the next day. So this system actually got laid out twice. Once by the contractor, and then once by me and one of our coworkers here. And it was because they didn't mind the splice. They didn't take care of where the splice was. And you can see it turned out really well. And it was a stained area here. Here's where our spot is that we stayed away from, because that was the expansion joint. So we stayed away from there. So the cable runs on each side of that expansion joint right here, because right here is where the expansion joint was. And that's why the cable is spaced away from that expansion joint. And yes, I know these cables are too close to go together. Those were fixed before. We were just kind of in the midway point, and I took a picture of it. So you can see what you're going to do in this case is this product has to be propped up on rebar, and they need to pour sub 3/4 inch aggregate concrete through this, because if the aggregate's too big, the aggregate will not flow to the bottom.
Right.
It'll act like a strainer. So we need to get that concrete, the whole mix, to get throughout the slab. So this cable is propped midway in the slab, halfway up, and it's a sub 3/4 inch aggregate that will pour through that and give you good results. So that's what a patio looks like here in the Midwest. And boy, that was a really fun experience putting that together.
Oh, boy. Thank you on that
Mhm.
one. Okay, so the big takeaway is follow the rules or the inspector will find you. We don't want any inspector problems on the job, so we do want you to make sure that you are following the rules that we give you. Using that 3-inch baseline to wire to on the flat surfaces and stair treads. As mentioned, the 2 to 3 inch depth embedment. We want that heating cable no deeper than 2 to 3 inches. That's your optimal placement for that heating cable to be most efficient.
And the National Electric Code says it has to be at least 1.5 inches below the surface. And
Minimum.
the National Electric Code also says with our cable, you have to have 2 inches of non-combustible medium below it. So you have to have 2 inches of non-combustible medium below and 1.5 inches on top. That's why this product cannot be installed on a wooden deck.
Mhm.
Wooden decks would never hold a 4-inch slab and support it. So we get questions all the time. Hey, I've got a wooden deck. Can you use can we use your cable? And the answer to that is no, because of the embedding rules. So that's very, very important. And Mary, because I say this at every webinar, I'm going to let you take the next one.
So the other big rule here we have is never cut the heating cable. That's a big, big no-no. They can never be cut or altered in the field. There's no way to just trim off a little extra, or let's say, let's order a 50-foot mat and put, 20 foot over there and put the other 30 foot over there and just cap the ends. That's not a solution. You cannot do that. We sell 20 and 30 foot pieces separately for that reason. So yes, you want to make sure that you can never cut or shorten the cable on site. And the bend radius, as Scott said, the splice itself is it's a little bit thicker. You will see it immediately. This is where the green jacketed heating cable meets up with the black cold lead wire. That splice section where the two butt up together is fatter, and if that joint gets damaged or broken or bent when they're trying to push it into the conduit, that will damage your heating cable. So stop before that happens.
Absolutely. And they broke another rule there is because the splice can't go in the conduit anyway.
Right.
So I don't know what they were trying to do, but it has to be outside. The splice has to be embedded in concrete or asphalt or whatever it is, because it heats.
Yeah.
And the National Electric Code says if you have something that heats, it cannot go in that tube. So it's very, very important to keep that in mind.
Yeah. You're
So-
protecting that splice from heating and cooling too fast and failing on you.
Right. Now, what I talk to people that get the spacing wrong is they will say, I put this, I know you designed it for 3, but I installed it on 4 because I forgot. I did 4-inch spacing. And now I put it in, all my pavers are in, and I've taken all the excess cable and I put it in a spool sitting next to it. I've talked to people at 24 times that have done that. You can't do that. You have to use that cable because there's nowhere else. I mean, you can do an area somewhere next to it, like if you build a walkway or something next to it to do 3-inch spacing. You have to keep the spacing. But if you have a little too much, you can go from 3-inch spacing down to 2.5. That's why we brought up the minimum bend radius, because 2.5 is the absolute minimum. Yeah, that's the absolute tightest that you can get it.
Okay. So when it comes to concrete and new pours, again, it's planning, guys. We want to have the map for your concrete guys to lay out the heating cables and make sure that they are specifically ready to go before the concrete trucks arrive, knowing where those J boxes are going, expansion joints are going. We need to have that firm anchoring. We're talking about the structural support for the heating system. So it's not just fastening it to the rebar that's really widely spaced. You need some sort of wire mesh. And we're not talking chicken wire, right?
Right.
We're talking like a 10 gauge
10 gauge
10 gauge
fencing.
fencing?
Yeah, 10 gauge fencing. You buy a big spool of it at a big box store.
Mm-hmm. Yeah, it needs to withstand the pour. I mean, that's really what it comes down to. The
And
cables.
it's not only the pour, it's the people walking on top
True.
of it.
Yeah.
Because when they're doing the install, they're going to be walking on the rebar or whatever that is, and it's going to want to sink down. Another big mistake I see, one job specifically was the 4th of July that I had to do the whole install myself, was where they had put the cable on rebar, but the
Mm-hmm.
rebar sat at the bottom of the pour. So instead of propping it up like they should have,
They pour.
they just let it sit at the bottom. So now there's 4 inches of concrete above it, and the product's supposed to be in the middle, not at the bottom. So that's why you want to be very, very careful with that, taking care of the distances above and below, making sure it's propped up in the middle of your pour. And just like we told you, the electrician needs to be there the day before, the day of, and the day after, however much time they need. You also need to tell the concrete supplier that it needs to be sub 3/4 inch aggregate. Because if you don't, they will show up with normal and it will strain, and all the water from the cement will go down below and all the aggregate will be stuck in the upper half.
Yeah.
So you have to tell them that ahead of time. And we have a great video that shows exactly like what we did. We shot a video for that job we did on that
Mhm.
patio, step by step, and everything that the concrete guy said, here's what you need to do. So watch that video. We got tons of videos, so check them out.
Absolutely. And the second thing we want to make sure is just going through and watching those thresholds too. Again, those nose, those steps. Think about tricky landscaping. Think about lighting. That's a big one nowadays. They put lighting in the steps. So those are things you want to be thinking of as well.
Yes.
Okay. In the field testing and emergency protocol, this is when it comes down to having, your electrician there before, during, and after, as Scott just mentioned. We need the guys to be testing out the cables. This is going to be done with your multimeter or mega ohm meter, megameter. This is critical. Okay, you want to make sure when you get your snow melting system, you check all your materials, check all the sizes, get them kind of laid out and where they're going to be placing and make sure that each one is there. When you do that, that's a great opportunity to take time to do that mega ohm reading and make sure that they are good to go from the start. Then, once you get them laid out, tie them all to the rebar or mesh and make sure that they are tested one more time because this is critical before you begin pouring. You don't want to pour it and then test it and find out, oh, well, that one was bad. Test first, then pour it. Once that's good to go, we will ask you to do one more final test, and then that test you should write and record for your records to leave with the clients or homeowners, and they can put that with their final warranty submission to us.
So a couple more things on this. Upon delivery, when you get the product tested, because what we run into a lot of times is they'll get big boxes of all this stuff. Then the concrete people will be there and they're ready to do the install and they test it for the first time and something happened to it between us and them. That's why you need to test it the day you get it, because then we can say, hey, you know what? This one roll tests bad. I've got a pour that's coming up in 2 weeks. Okay, perfect time. We'll get you the replacement. And now you're not up against it. But if you don't test it when you get it, you are going to be there the first thing in the morning and go, uh-oh, we've got two that someone ran over with a truck or something, right?
Mhm.
So you have to watch out for that. So test them the day you get them. And then I also do the 3-stage on on that day, but I always test upon receiving them. Two big differences. The multimeter is used for testing ohms. The mega ohm meter is used for testing the insulation between the two heating wires and the ground that are inside the wire. We're testing the insulation value between the one core wire and the other core wire to ground by sending 500 volts down that line. So a mega ohm meter is actually testing the wire under stress to see if it's going to be good. A multimeter does not do that. So many electricians have mega ohm meters. If they don't, they're readily available. You can find them everywhere, but you're going to need both to do this job.
Good to know. Yeah, good to know the difference because people may not realize there's a difference there. So what do I do if I accidentally cut my cable or hit it with my shovel?
Stop, because of the first job that I ever went on, the installer was doing an asphalt job and they had those rakes that they like to move asphalt around. Well, that rake went down into, he went wham, right down into a cable, and we had to mark that location. We just put a foot around it, kept it open, and then continued to work to get it all laid out. Then we came back the next day, made the repair. Then they came back the next day and did a patch on that spot. You couldn't even see it because it was covered with a sealant after that. But stop working, mark the location, block it off. Then if you have to get a splice kit, we'll get that to you, but don't cover that. If you know that that's the bad spot, don't cover it. One bit of prevention is to make sure that you turn those rakes upside down and you use it to move. Everybody's seen landscapers moving dirt by turning the rake upside down. Do it that way, or put tape or duct tape on your shovels, because that way you don't have such a sharp cutting edge on there.
Absolutely. So here's where it comes down to managing too much or too little cable. So prevention is really first. What we would like to make sure that you're never doing is the golden rule here is the Ohm's law. It's not just a rule, it's a law. We never want you to cut the heating cable. These heating cables are engineered with a internal fixed resistance. So even just like I said, cutting off, a foot or two of the heating mat or cable will not only void your warranty, but it will effectively destroy your heating system because it's not going to work at the right resistance that it's supposed to. So we understand that real world changes happen and that, somebody changes the dimensions or they added a little wall or something or a sitting area or a fire pit area that you weren't planning for. You had this whole patio plan and here's this fire pit now that they want to build in there. Well, now you're going to have too much mat because you can't put the mat under the fire pit. We understand that happens. When that does, get back to us right away. Give us a new dimension or mark out on the smart plan you have the new changes. We can send that into our engineering team within a few hours. We can usually get you back a alternate solution to use the material you already have on site. Or if it's not able to be reworked with the material you have on site, we will get you up the correct size piece of material right away.
Yeah, one of the main misconceptions we have here is people never call us. I work in tech support, right? People never call us in tech support and go, hey, I had a perfect install. Thanks. Bye. That never happens. They call us and go, oh, jeepers, everything is going sideways here. What do I do? It's two completely different situations. So Ohm's law cannot be worked around. So what people think is we have a gigantic spool of this snow melting cable out in the back, and we just take it off and we cut it into lengths and we send it out to you. Each one of those lengths is sized with ohms per linear foot, because more ohms, less ohms is going to affect your current. So to keep it very simple, Ohm's law, the more resistance, because this cable is a great big resistor. So the more cable that you cut off, you're removing resistance. When you remove resistance, your current goes higher and higher and higher, which means if you cut a cable in half, it's going to draw twice as many amps.
Oh my God.
It's going to get incredibly hot. That's why you can't just cut a mat in half or 2/3 or whatever. The more mat that you remove, the more current is going through your system, which means hotter, 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 and hotter. Every cable is a certain ohms per linear foot. There is no big spool that we just, okay, this guy needs 700 feet. You just don't pull it off.
Right.
It's all sized by the ohms per linear foot. So what happens if you have too much? Then you are going to tighten. You can go down to 2.5 inches if you have to. And then if you still have too much, what you can do is utilize like the buffer zone, because sometimes we leave 6 inches on the side. You can go into that 6 inches as long as you don't get the cable any closer than 2.5 inches. And if you still don't have enough, well, then you're going to build a walkway. And you're going to install the walkway per the instructions, and you're going to space the cable. That's all you can do. You can't cut the cable off. So if you don't have enough cable, what you can do is you can go from 3-inch spacing to 3.5-inch spacing, or to 4-inch spacing. But remember, when you increase your spacing, the further apart the cable gets, the fewer watts per square foot are going to be in that square foot, which means it's going to take longer to heat.
Right.
That means it's not going to get as hot. So that's why you can't just go from 3-inch spacing on the plan to 5-inch spacing, because once you get to 5-inch spacing, you may not get any melting.
Right.
So
right.
it's very, very important to keep that in mind. So if you run into a problem, give us a call. We'll help you figure it out.
Absolutely. So when it comes to code and structural restrictions, the NEC is what mandates it. So adherence to your code is very important, and specifically your local code too. We're always going to make sure that you're checking with your local code authorities, who is going to give you the inspections. They're going to have the final say so. But on all of your documentation from us, when you get your smart plans, we are going to call out the GFEP breakers. These are called ground fault equipment protection, and they have a 30 milliamp trip. This is not the same as your standard 5 milliamp with a GFCI, that prevent nuisance tripping. This is a heavy duty breaker. It is required. They are expensive. We do not provide them. So plan ahead for your breakers. We will call out on your plan how many you will need, but a good rule of thumb is to get those planned out really early in the project.
People always ask, well, why can't I use GFCI? Well, first of all, it's not code compliant. And the second thing is it trips more often. So if you want a system to be reliable, you're going to get the correct circuit breaker. If you want a system that is sometimes, oh, that section's out over there, that section's out over there. Well, why does that section keep going out? Well, that section's on a GFCI circuit breaker, and that circuit breaker is tripping every other time you use it. That's not the kind of system you've invested in. You want it to work every time. And if you put GFCI circuit breakers in, sometimes it'll work and sometimes it won't. So that's where you're going to see sections like where that whole mat is that's powered by that breaker, that whole section will be covered with snow where the rest of it melts. So you need to watch out for that. And you also need to get that visible thing in your driveway or in your sidewalk that says this is heated. So someone just doesn't come, hey, let's just go ahead and break this up, just like that, and boom, your system doesn't work anymore. So it's very, very important to follow those electrical rules. Always ask your local authority having jurisdiction what specific rules you need to follow.
Yes, that's correct. And we do provide you with that identification plaque too on your jobs and quotes. So you could get that right.
Well,
from
people
us.
always say, I don't want to spend the money on that plaque.
I know.
Well, if you want to comply with your local code and have it not tagged,
Yeah.
then you better use that plaque that we're giving you.
Absolutely.
Yeah.
Absolutely. So the cold lead management, as we mentioned, if you are using 120 or 240 volt systems, you're going to be with a 20-foot cold lead. So that is meant to route yourself to the J box. That doesn't necessarily mean a 20-foot cold lead is going to get from your patio in your backyard all the way to your breaker panel. It's not meant to go that far. It's just meant to get into your J box. So that 20-foot lead with the 120 and 240 volt systems, if you are doing commercial projects in the 208 or 277 volt, you do have a 50-foot lead wire, right? 50-foot lead wire, a little bit longer, so that's like a little bit easier when you have very large commercial buildings to get into with your cold leads. So routing that to the shortest plan possible, telling us ahead of time, is the power coming from the building on the left side or the right side, just so that we make sure that your heating cables never cross your lead wires. That lead length, though it's 20 foot, you can shorten it if you don't need all that 20 foot, but extending it has to be in that junction box and it has to be watertight. So we do also provide, or we'll spec for you, the in-ground junction box, or the large or small size, or the large wall-mounted junction box. So if you're not putting it in the ground, and when we say ground, this is not something you drive over, right?
Right.
Right. This is sort of how it shows
Off the
there
side.
in the dirt, kind of in the landscaping. It is waterproofed so that those connections stay watertight, but we do want you to use the junction box instead of trying to, that's how you would have to extend them.
Yeah, if you look at this picture right here, all of these wires have been trimmed to the correct length. The local code will tell you how long those leads have to be. So those leads have to be at least a certain length. So the electrician is going to measure them. He's going to cut them, or he or she is going to cut them, and then that's where the connections are made. Never assume that you're going to make any of these connections. Hey, I need to buy some lead wire because I want to make an extension in the slab. That's not going to happen because it's against code. And if that splice that you are manually making yourself ever fails, guess what? You're going in there with a jackhammer and you're paying for that because you've broken the code and you've not followed the instructions. So this is what a junction box looks like. This junction box has been installed. The excess cold leads have been trimmed off, and now it's ready for the connections from the wire being run from the house or the garage or wherever out to this junction box, because that's where your connections are made.
Right. So placement of those, again, you got to let us know ahead of time where you're going to put those on your plan. I had an example for a guy I think it was just yesterday, he wanted a 3x60. We don't actually have a 3x60, right?
Mhm.
So I advised him that we could do a 3x30 and another 3x30, and then you butt the two starts together and you put one J box coming out to the side. Unfortunately, he didn't want to do that. He wanted it to be continuous. He's like, no, I don't have anywhere to put a junction box. So, but we did have to talk him around to figure out a way to do that. So, yeah, you definitely have to think about the J box placement ahead of time.
Yeah, and the National Electric Code says that you need 3/4 inch rigid metal conduit to go from that. It needs to be butted into the heated area because that cable has to be protected. That cable, that black cable should never see the light of day. It's not rated to run in dirt. It
Mhm.
needs to be in conduit. And as we talked about your electrician, your electrician has got to be out there the day before or
Piping,
two
yes.
days before because all of this labyrinth of wires, not wires because the wires aren't in there yet, but the box and all these tubes have to be there because that's what you're running the cables through.
Right.
So that all has to be done in advance before anybody shows up to lay it out.
Absolutely. Here's something that we also have to mention too is the placement for your
Oh, Mary,
fire
I'm
hydrant.
sorry. Before I forget,
Okay.
sorry, I hate doing this, but I said 3/4 inch rigid metal conduit. That's a National Electric Code. The code book will say, or other approved means, which in a lot of communities now is becoming PVC.
Okay.
So don't come at me with, but you told me it has to be whatever your local code requires or allows, but the national code says that. So code says this, but the local guy, the local gal, or whoever's doing your authority having jurisdiction is going to tell you PVC is okay or not.
Hmm.
Otherwise, follow the NEC. So
Okay.
want to make sure I said that
Good.
before anybody got that.
Yeah, don't come at us for
Yeah.
that. All right. So strategic sensor placement for stairs and landings. Um, this is important. Wherever you're going to place the sensor, most folks always want their snow melting systems on an automated sensor. Nobody wants to have to worry about getting up at 2 a.m. when the snow starts flying to turn on their snow melting system, right? So we suggest using the aerial sensor. The aerial sensor is a great device. It detects moisture and temperature. It has to have both to activate. This can be mounted on a mast or like a wall mount. It's above ground placement. You can mount it sort of out of the way, where it's not obtrusively seen in your home. It could just has to be receiving the snowfall in the same area where your snowfall system is.
Yeah, that's what we tell people when they're thinking about where their sensor goes. First of all, we have a video that talks specifically about this, but it's going to be, think about like right now, think about where the snow always hits in your yard or on your sidewalk or whatever. That's where you want the sensor because the sensor needs to be hit by snow every time it snows. And you have to be able to get at it. So don't put it on a 30-foot stalk on the top of your roof that no one can ever get at because birds love to sit on that little sensor on the top. And what they do is they leave behind a little gift every time that they've sat there. And what happens is the only maintenance that you need to do on an electric snow melting system is to clean the top of the sensor. So that sensor has to be somewhere where you can get at it, but a vandal can't just go, hey, this is cool, boom, and throw it away, or break it or whatever. So it's got to be where the snow always hits it.
Mhm.
It's got to be somewhere where, if you decide to put it somewhere in the vegetation next to your driveway, you need to make sure that if your sensor's sitting here, that the bushes in 2 or 3 years don't start growing over the top. I see that all the time,
Mhm.
but I don't want to trim it back because it looks so pretty. Okay, well, your sensor is getting blocked. You don't want snow blocking any of those access to that sensor. So that's the important thing
Mhm.
for aerial sensors.
Yeah, and also think about don't put it too close to your vent, your
Oh,
HVAC vents, your dryer vent or something. That warm dryer vent's gonna not activate your snow sensor when you want it.
the number one problem that we see every year is where someone puts the sensor right next to the house.
Mhm.
So, because no one wants to see it, so they'll put a junction box right on the side of the house, and then you'll see that sensor, and
Mhm.
there's not a bit of snow around it anywhere. That's the number one problem we see. Don't let somebody stick your sensor right next to your house.
Yes, absolutely. That's very important. So please make sure that that is in a good location. It's not going to be, kicked by somebody or hit with a weed whacker or a lawnmower. So for those kind of placement, it's very important to forethink that. Sometimes you're going to be going with an in-ground sensor though. When an in-ground sensor is exposed, it is kind of in the slab. This is something that we're going to recommend. You could get away with using it for asphalt and concrete, but maybe not so much with a paver application. We'd probably
Yeah,
like
never
to
with a
see you,
paver. Nope.
yeah, we'd like to see you go with that aerial sensor anytime you're doing pavers.
What happens is a paver starts here, then
Hmm.
after time pavers start to sink. Well, if your sensor's here and your paver's nice and even with it, 2 years later, the paver's down here. 3 years later, the paver's down here. 4 years later, now all of a sudden you have a sensor sticking out 2 inches above the surface of the driveway. That's why you never use them with pavers.
Right. So, yeah, we do want a nice flush pavement mounted sensor if you are doing it for that other application. Um, this is good. A lot of times, if you're doing a sensor application, slab sensor application, this is going to be like your high efficiency, like concrete pours, right?
Asphalt.
Asphalt compliances. Yeah, you're going to check all that stuff to make sure that this is the right type of sensor for meeting your requirements. Some codes, depending where you're at, may require a slab sensor. So that might be the right way to go.
A perfect application for a slab sensor is a car wash.
Oh yeah.
Car washes, 9 times out of 10, if you ever go and look at a car wash as cars are going through it. The cars are going to be going through this car wash and this whole area around the outside, outside of the door is going to be wet.
Mhm.
Well, what you want to do is you want to put that sensor in that area so it doesn't freeze, but you don't want to put the sensor where the tires always go.
Right.
Right? So on a car wash that you'll see the tire tracks continuously. People are always driving out the same way. Put that sensor either in the middle of them or just on the outside of them. So that's a perfect application, but you have to think about where the sensor goes. Don't put it where it's going to get run over all the time.
Yeah. Just choosing the right one is for best performance and efficiency, and we will help you with that decision to guide you the right way. We've got great videos. We've even got some tech articles that can help you choose the location for your sensor.
Yeah, slab sensors are good for mission critical jobs like someplace where it's because what happens is you're putting it somewhere where people are always walking, or you want to put it in the area that's most important.
Mhm.
So that makes sure that if you have an area that, by a doorway or something that people are always walking, mission critical is to make sure that that space is clear. The aerial sensor may not see this snow, but you may have water that's dropped on here and has frozen. So those are the kind of things you want to think about.
Absolutely. So the road to success is, here's what it looks like. We have your master checklist. These are the 5 golden rules. There's 5 of them. The number one, always, 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 never cut the heating cable. Again, they are fixed length cables. You cannot cut them, you cannot shorten them. You have to use the right spacing as designed to get the best optimal performance of your system.
You know what we're also never going to have you do? We're never going to have you splice the end of one to the beginning of the other.
Right.
We're never going to have you do that because we talked about Ohm's law, right? The more that you cut off, the less resistance you have. Well, the more that you add on, the more resistance you have. So the more as resistance goes up, the heat goes down. So if somebody says, I have 2 of these, I hooked them together, and now they don't get warm because you've added a whole bunch of resistance, but you still have the same amount of power going through it.
Right.
So it's always inverse. More resistance, less heat, right? So keep that in mind. That's Ohm's law. That's why you can't add or subtract.
Correct. The factory and splice has to be embedded, as mentioned. This is the part that cannot go into the conduit. It has to be protected because that is a part that's still heating and cooling. So we do want that protected by the concrete, asphalt, or embedding material.
I also want you to protect the factory splice while you're doing the install. And what I mean by that is when you're doing a concrete pour, there's going to be people walking all over the cable attached to the rebar, right? So what you want to do is you want to take a flag, like a construction flag or a Julie flag, for marking utilities. You want to take one of those flags, you want to put it right next to that splice so it sticks up. So whenever the people are out there laying the concrete and they run into that flag, they know, oh, right there is the splice. I need to make sure I don't step around here. And what's cool about those those construction flags is once you're almost done, you just pull them up, make a little swoosh, and you never even knew they were there. But you have people walking around on that product. Every place you have a splice, put a flag in, and then just pull it out when you're done. As you move away, pull them out as you go.
That's a great tip. Thank you. The other one we want to mention too is your expansion joints. How to protect that structural shifting. Expansion joints are super important, guys. We don't want you to have a cable that goes through two separate monolithic pours of concrete. What can happen is if one slab shifts or moves, your cable in the middle can get sheared off. So that is something we need to avoid. I have a project coming up with a guy that's got the most incredibly long driveway. Although we can only do tire tracks because it is such a long driveway. It's like 450 feet. But he can't pour all that concrete at once and do this. So he's gonna have to tell me where those expansion joints are as he's pouring it. So yeah, that's how that one's gonna work.
Yeah, I went out and worked on a couple times in a hospital in New York where they had run the cable through an expansion joint
Mhm.
and they had two areas that quit heating. And as soon as we found out,
The slabs.
the slabs had gone like that and the cable just snapped in half.
Yeah.
So that's why you don't do it, because that's a big problem to fix when you're in the front of a hospital and people are walking through there all the time and all of a sudden two sections don't work.
Mhm.
Well, those two sections were a cable started here, ran through an expansion joint to a section over here.
Mhm.
And now neither one of those work.
Yeah, that'll ruin a system really quickly. The testing is really important as well, guys. Take your digital ohm meter, take your megameter, get it on delivery, check your product when you receive it. Hopefully you're ordering enough time in advance that you can inventory all that you received to make sure that it's all there, it's all tested properly before the day of installation, because if anything comes up, call us immediately and we can correct anything that has gone differently from when we originally started planning the project.
Yeah, and the installation manual shows you exactly how to do that. And don't forget your GFEP breakers.
Yeah, absolutely. So do we have any questions here? I think we got a couple that were sent in ahead of time.
Well, that first question, ding, 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 is automatically Will Robinson, danger, Will Robinson.
Yeah.
Can I cut the heating cable if it's too long for the stairs? And the answer to that is no. You can never know. You can never ever do that because we've explained Ohm's law here in the simplest possible terms. And now we know why you can't cut resistance cable. So very, very important to keep that in mind.
Another question we get is how much does it cost to operate a snow melting system? Well, we are going to tell you that when you send in your plans and we give you back your smart quote. We give you a little estimated operating calculation there. So we kind of take again, a lot of that guesswork out just by getting your quote and smart plan from us.
Yeah, and Andrew asked a question about the aerial sensor. It's a very good question. It monitors the temperature and the moisture, right? So you have to have, it has to be wet while it's below a certain temperature, which means anytime it's below 38 degrees, it's going, okay, I'm ready. It's 38 degrees. Now I'm looking for any type of precipitation, whether it be snow or rain or anything like that. Now, if it's 40 degrees, I'm not looking for that because both conditions have to be met. So it's 36 degrees. Okay. As soon as I get below 38, I'm waiting for water to hit me. So that's what it is. 38 degrees and wet, then it will kick the system on. So great question, Andrew.
Thank you. Another question we get all the time is how quickly do these snow melting systems melt the snow?
Is it 37 degrees or is it 20 below?
Well, that might depend.
You're right.
Did you
So
space it at 4 inches or 3 inches?
it depends on if they needed that spacing or not.
Is your paver 2.5 inches or is it 3 inches?
There's just so many, and it's a question we can't answer because it depends on what the temperature is. But all you can do is say, we've been doing this for 20 years, and what we see is average about 2 to 3 inches of melting per hour.
Right.
Some days it will be much longer duration than that. Some days when it's 38 degrees and the sun shines, it'll be much less than that. So there's no way I can answer that question. So 6, 7, 6, 7, right?
Here's one that we get also is, will this work on a rural driveway? I can tell you, no, unfortunately. As a person who owns a gravel driveway.
Well, is it gravel or rural? Because if you have pavement or asphalt in a rural setting, then yes, it will.
Rural, yeah.
Gravel is the word I think we might have been looking at.
Yeah, gravel driveway would be a no, unfortunately. There's just no way to protect the heating cable with that. And as you know, when you have a gravel driveway, After a year or so, those ruts start coming through, and you're going to have really big problems if you try to put a snow melting system under that. So definitely not a gravel driveway. It does need to be a hard surface.
Yeah, the National Electric Code requires it to be embedded in asphalt, concrete, or under pavers. All of those are very, very hard substances. So,
Ali, yes, we will be recording the session, and you can watch it later. We'll get that over to you in an email later.
so we have a couple questions. One of them is from Christopher. Do you have to install the slab sensors or can you just control it manually? Well, if you're in a state that isn't New York or New Jersey or Vermont or Colorado or any of those other states that require you to monitor the temperature of the slab, what that means is usually, in a nutshell, those states are looking for any time that the temperature of the slab goes above 50 or some other arbitrary number around 50, the system should shut off automatically.
Right.
That's their code. So you can't accomplish that if you don't have a sensor in your slab. So if you're not in one of those states, then you can control it with a timer, or you can control it with a Wi-Fi switch or anything like that. Just talk to Mary in the sales department. We do have options like that. So yes, you can do that. And then Steve had a question. My clients need ramps that are reliable and safe. It sounds like this product will work for anything masonry, but I cannot use it for anything else. Do you have a product that can go under composite materials?
Good question. We get that asked a lot too.
And that's kind of like the
Decking.
composite material decks.
Yes.
Same answer.
So unfortunately, no, it will not work on your composite decks or your wood decks. This does have to be embedded under concrete, asphalt, or under a brick paver. So masonry materials, yes.
Yeah. Cementitious is the word they use. But yeah, that's a great question, Steve. We get that question all the time. So yeah, it has to be embedded. There are products that you can purchase. We don't sell them. But like the Miracle on 35th Street, if we're Macy's, we're going to send you to Gimbals. Then yes, there are companies that do make mats that you can put on top and you can melt the top surface. So that might be the way you want to go, Steve.
Yeah, like a more of a removable mat style system. Okay,
and I think
that
that's
brings it up. Yeah, great questions, everyone. So to wrap things up for y'all today, we're going to close today with some resources that we're going to send you. So you are going to get a PDF of all the slides from today's webinar. We're going to give you the 5 golden rules, and as well as a rewards coupon for sticking around and watching with us. So you'll get a whole rewards coupon and the recording of the webinar. And to follow up this amazing webinar, Scott has done his monthly pro tips on the 5 golden rules that we just told you about.
What a coincidence.
Yes. So thank you so much for that, Scott.
No problem.
Next month, we're going to be doing another webinar. I'll be back again. We're going to be talking about indoor bathroom floor heating this time. This is going to be all about tile and advanced installation tips for how to do radiant floors under our favorite tile flooring.
Yep. And if you have any questions, you can always give us a call. If you need technical support, we have a line that's dedicated for people that are having issues in the middle of an installation. Now, we don't answer, hey, do you have this product? Or, hey, how much is this product? Or how often do I need to, it's not a sales line, but it is a question. If you're in the middle of doing an install and all of a sudden you have too much cable, then you can give us a call at 800-875-5285, or you can send us an email and we'll always be glad to help you. So thank you for watching, everyone. I want to thank you for taking the time, and hopefully we answered your questions, and hopefully we piqued some interest. And if you have any questions, feel free to call us.
Absolutely. Thanks, everyone. Take care.